screen. This thing won't go away, but that's okay because we're shortly going to cover it up with objects1. Okay. Today's lecture is going to be about objects. Specifically, it's going to be about object literals. When you hear me referring to object literals, I'm going to mean the curly braces with the key value pairs. The reason I'm going to make that distinction is because I want to illustrate the fact that arrays and functions are also objects, even though in the real world, for the most part, when people say the word object, they're referring to curly brace, key, colon, value, curly brace, which is what you're going to be seeing here. So in this lecture, we're going to talk about what an object is. We're going to talk about why it's useful. We're going to talk about what happens when you use the type of command on objects. We're going to talk about accessing, adding, changing, deleting values, the in operator, and then how the in operator is used in the for in loop. We're going to talk about two methods native to the global object that is capital O object, dot keys and dot values. And we're going to talk about nested arrays and objects and how you can have arrays inside objects and a little bit vice versa. Before we get to all that, let's talk about what the definition of an object is. An object is a collection of key value pairs. So it's a bit like arrays in the sense that they're data structures that are helpful when we need to store multiple values of something. But what we get from objects or object literals that we don't get from arrays is this key. This key is really, really useful when we want to sort of intelligently associate the value that we're storing with like a version of metadata. Metadata is just this idea of data about data. And in a way, you can think of this key as something that describes this value. So these two things are not very descriptive, but shortly we'll see how they can be used. All I want you to get from this slide right now is that the way we access values of keys in an object literal, or one of the ways we can do it, is via bracket notation. The same way that we're doing it, the same way that we're using bracket notation for arrays. Question?
Are objects, are they basically dictionaries?
Yes, there are a lot like dictionaries in them. That's all I feel comfortable saying, though, because it's been like literally a year and a half since I touched Python. But if you know Python and you've used dictionaries before, this is the same general concept. Now, let's talk about why objects are useful. And specifically, we're going to do, I should have worn my machine chart. I'll wear it tomorrow. Why are objects useful? So let's say we have a bunch of data about Pusheen the cat that we want to represent in a collection. So if we did it in an array, we could have the name Pusheen, the number 7, and the string gray and tabby. So we're all smart people. We can use context clues to sort of make guesses about what that information represents in an object called Pusheen. But A, it's not good to make that assumption because, as my template says, users are stupider than you could possibly imagine. And B, sometimes the data that we're storing is not as context friendly. Sometimes you need to be able to distinguish between like an ID number, a secondary ID number, a social security number, and like other things that if you just stored in an array would have no context. Objects keys, which are always strings, that's why they're in ticks here. Objects keys are always strings, allow us to associate certain values with helpful handlers. So when we create an object literal called Pusheen, we still have this collection of values, but now we associate those values with an indicator of what they are. So Pusheen is a name. 7 is the age of Pusheen, and gray and tabby is the color of Pusheen. Does that make sense to you guys? Cool. So when we do type of object, we get object. That's fine in this case, right? It was a problem when we tried to do type of an array because that was object as well. But type of object is an object. This slide is just to illustrate that object literals are what people mostly refer to when they talk about objects in JavaScript. But yeah, if you need to assess whether or not something is an object, you could do type of that and it's an object. You're good. Julia.
Are there other kinds of objects besides arrays and objects?
Functions. Functions are objects. I think. Alex, are functions objects? Yeah. Okay. I like my cat was all up in my business last night. I haven't been to sleep, so if I seem crazy, it's a combination of that and the construction. Be gentle with me. But yeah, arrays, object literals, and functions are all objects. So let's talk about creating objects. You can create an object largely in the same sort of pattern that you create an array. Just instead of square brackets, you're going to use curly braces. This is the same Pusheen object literal that we looked at earlier, but I just want to call attention to the fact that we've got a let here. If we wanted to make this an array, we would just do let Pusheen and then square brackets, curly brackets. Let's talk about accessing values in objects. Now, anyone just throw out for me how we access values in arrays? What? I can't hear you because there's a huge jackhammer. By index, but specifically, what is the character that we use? Square brackets is what I was looking for. The good news about objects is that we can do the same thing with one slight difference. In arrays, as Julie pointed out, we access them by index, which means we plug the index that we want to retrieve in between the square brackets. Here, we're not using an index, right? Because indices aren't how we store and look up values in objects. We just pass in the key, specifically the string. Everyone see this? See how this works? So, what do you think is going to be locked by this? Lillian. Yeah. And to this last point, it's just the same as when we tried to access the fourth index of an array that has 3 indices. It's undefined. Will.
Are there any benefits to using bracket notation to dot notation?
We're going to talk about dot notation. And then the answer is personal preference. And, well, no, it's not. We're going to talk about dot notation. Don't make me get ahead of myself. Jackhammer, no sleep. Be nice to me. Okay. Yeah, it's important to note that when we're using bracket notation to access the value of an object literal, in the previous slide we passed in strings directly, but bracket notation is super useful, and we'll get to this in a second, or I'll expound upon it when I introduce dot notation. Bracket notation is really flexible because it allows us to pass in expressions that evaluate down to a string. What do I mean by expressions that evaluate down to a string? I mean 2 strings that are concatenated together, or a variable whose value is a string. Any questions about this? Yeah, of course, of course. And always, I should have said this before we were halfway through the course, always feel free to ask me to repeat things. We're moving at a really quick pace in general, so I'm happy to repeat things. What is cool about bracket notation, accessing values of an object literal with bracket notation, is that the thing inside those 2 square brackets only needs to evaluate to a string. So if we pass in a string literal, we're good because a string literal is a string. But we can also do stuff like pass in expressions. One string plus another string. That operation happens, and we get the string color. Well, I'll just try you guys. We get the string color that logs gray and tabby. Because call plus or color, the key color is gray and tabby. Same goes for this expression key to check. We don't have a key called key to check, but that's okay because we're not trying to find the value associated with the key in the object called key to check. We're trying to find the value associated to what the variable key to check evaluates to, and that is the string name. Did you have a question?
Could you put a more complicated function in there? Could you call a function inside?
Yeah. Yeah, you could if you had a function that took an input. Yes.
Where's the string?
Yeah, as long as the expression evaluates with a string, then it will check the object literal for the value associated with the key that is that string. Julia. I'm going to stop you right there because the answer is no. Keys in object literals are always strings.
We're always like alphabetic, not even if you were to put like a number in quotes and then
Oh no. If there was something here called 1, and if there was a string 1, and you passed a string 1 into here, then yeah, it would return that value.
okay, so
But keys are always strings.
yeah.
However, there is an ES6 feature called set that looks a lot like an object literal, but has some differentiating features. One of which is that you can have non-string values as keys, which is actually pretty cool. It means you can have an array as a key, for example. You can have another object as a key. But when we're working with object literals, all we just have like our keys are strings.
So if you had a key that was a string that had a numeric character in it, and you put the numeric character without quotes into bracket notation, would it kind of type yours?
Possibly. Try it and let me know. Any other questions about the code on this slide? Perry? I'm so sorry, but I actually literally can't hear you.
Just general practice
No, it doesn't. I've literally never seen this. This is just to illustrate that it happens. This, on the other hand, happens all the time. And specifically when it happens, I'm going to pull up a REPL and show it to you guys. I'm just going to do this anyway. Might as well do it now. Let's do something more interesting. All right. Sorry, this is ridiculous, but it's less ridiculous than me taking 25 minutes to type. I love my cat. Oh, we should probably label this. Truth. Let's say I wanted to. So normally I do this little example later because it's going to incorporate how to add string or how to add key value pairs to object literals. But all you need to know about adding objects to key value pairs, adding key value pairs to objects is that like if we have an object called truth object and I wanted to add something to truth object, what I would do would be like truth object test case. So you can see here that I use bracket notation to put a string literal inside the. I use bracket notation to add a key value pair to the object literal. I put the key as a string literal in brackets, and I made its value another string. However, I could have made that value anything. I could have made it null, and then we'd get that. I could have made it a really long number, and then we would get that. Make sense? Hold on. I'm not going to call on you right now because I want to go through the importance of like bracket notation and why you would use it instead of dot notation, which we'll talk about later. And by later, I mean like very shortly. But for now. I have 2 cats. I don't want one of them to feel bad. Let's say, Perry, that I wanted to make each word, I wanted to populate this object with each word being the key and each index that the object was, that this value was at in the array as the value. One way I could do it would be by directly typing in key value pairs the same way I did earlier. Truth object I, 1, truth object love, truth 2, but like this is exhausting just now. Imagine if this object had 100 key value pairs. It would be ridiculous. What bracket notation allows us to do, and the fact that the expression in here is evaluated, means that we can do this. The putting a variable in bracket notation happens all the time. And usually it's something like this, where you have a dynamically changing value that you want to utilize programmatically. You guys see how this works? Any questions about this?